Today we will see image enhancement technique. So whenever we talk about image enhancement, normally we talk about enhancement of quality of an image. What is the meaning of quality of an image? We will see later, but right now we will focus more on this topic on improving quality of an image. Now whenever you are trying to enhance an image, normally we process an image in two domains. First domain is known as spatial domain, that is we process with pixels values of an image. What we are doing basically, we are trying to improve the quality of an image by manipulation of pixels values. And second important domain where we can work is known as frequency domain. So image can be enhanced either by doing operation over spatial domain or by doing operation in frequency domain. If we talk about frequency domain, basically we are talking about Fourier transform of an image, where we are performing operations. We are first of all obtaining Fourier transform of an image, and then we are processing that image. Sometimes we also use combined method where we apply both techniques. We apply manipulation on pixel values also, and at the same time we try to operate over Fourier transform of an image also. Now what it basically indicates to that image enhancement techniques, basically sometimes we are trying to improve the quality means sometimes we want to highlight an area of an image, to get more and more details of those points. Sometimes we try to remove, let's say, noise present in an image, So these kind of operations comes under quality improvement enhancement techniques of an image. So roughly we will see some other cases also. Improving quality is a subjective terms, you can say. Sometimes you improve contrast an image and you feel better by looking into that image, and sometimes some people may be looking an image with less contrast. So it's very subjective in nature. So but more or less you can see the details. We are trying to highlight something over an image, and then sometimes we try to remove basically the noise from an image. That's the basic about two things, how to improve the quality either by using spatial domain techniques or by using frequency domain techniques. Now if we see directly come to the point of spatial domain, we are coming to the point of how to enhance an image in spatial domain. Now you normally know image plane basically consists of x and y plane. You know, normally we have already talked about these 2 points. X is in horizontal down direction and y is x is vertically down direction and y is on horizontal axis, and this is known as its origin point. This point is known as origin points, and in all these places there are several coordinates, let's say. Fine. So let's take an example of 3x3 image pixels points or any other points which is present here. So if we talk about 3x3 image, 1 2 3 1 2 3, so these points will be under consideration only. Fine. So let's say this image is represented by f of xy. That particular point is represented by f of x of y. So whenever you are directly manipulating pixel at xy position, let's say, and along with its neighbor also, then you say direct manipulation of pixels, then we say we are operating on which domain? We are operating on spatial domain, because you are simply operating over the coordinate value. What are the basic operations that we are trying to do it here? First of all, we are trying to do it here intensity transformation. Sometimes we try to improve the intensity values of the pixels. So first operations we will see about intensity transformation, and second things we will look into one another aspect that is known as spatial filters or spatial filtering method. Two more points are important here. 2 points are important here, you can say. Intensity transformation, how do we do it, and then how to apply filter. The basic things mathematically, if you want to see, we are getting g of x of y if we are applying one operator, let's say t, over the function f of x of y. This is the very important point. T is here known as what? T is known as operator. So whenever you are doing over spatial domain, what we are doing basically, we are simply obtaining g of x of y by applying an operator t. Fine. So simplest case, if I tell you about the simplest case, size of the neighborhood would be 1 cross 1. Okay, not rather than 3 cross 3, it would be 1 cross 1 size. Clear? Where t is also known as operator, or you can say gray label transformation. What you are doing basically here, you are simply trying to intensify or mapping of your intensity value at xy with some operator and trying to get back some g of x of y. Clear? Sometimes you write the same equation, g of xy equal to t of xy is like this also. You are obtaining your resultant image S by applying t over r. Clear? S is your what? S is your output image, r is your input image. Input image, pixel value, and S is your output image, pixel value, and T is your transformation, or you can say operator. Now we will see the operator T, how it can change the intensity or how it can make manipulation in spatial domain. So two things we will see right now. One thing is known as contrast stretching and another concept is known as point processing. Two things we will see right now. One thing is known as contrast stretching. Contrast stretching, and another point we will see right now, point processing. Two important concepts whenever you are talking about spatial domain processing. One concept is known as contrast stretching and another point is known as point processing. So let's take an example of contrast stretching. So simply you draw a diagram, let's say. Over an axis you are drawing R. Here you are getting back your S is equal to T of R. Clear? And let's say you have a threshold value here M. You have a threshold value here M, and you from here you are getting back something like this. The graph is representing like this, and here you are applying T of R in this point, let's say. Clear? So anything below M, below the threshold value M, will be falling where? Will be falling in which side? Darker side. Will be falling on darker side. And anything above M will be falling in which area? It will be falling in lighter side or light area. Clear? Similarly, anything below M in this side also representing what? Dark, and anything beyond that will represent light. So this is known as contrast stretching. So you have a threshold value M. Based on M and applying an operator, you are getting an image which may be less in contrast or more in contrast. Second kind of operations you can see as a point processing. So you are processing over a point. Same way you are getting one kind of signals, you can say threshold value M, and beyond that everything is light, and below that everything is black. Clear? This point is clear. So this is S is equal to TR. You are getting S is equal to TR. Here dark area and here light area. Clear? Dark area, light area, and this point will be represented by R. So simply during point processing or contrast stretching, you are trying to manipulate intensity value of your pixels. So gray label transformations you are doing by using some operator that is known as T. So simplest mask here, basic process of operator, you normally try to process your whole image pixel by pixel. So normally we create a mask. Normally we create a mask to process each and every image pixel points. So basic small mask in a 2x2 array or 2D array will be of size 3x3. Okay, and these masks are also sometimes known as what? These are known as filters, kernels, and sometimes they are also known as window. Someone will create a window of that size, or sometimes they may be known as template. Okay, so they all are the same things, but nomenclatures are different, knowing by different names. So basic size of mask will be 3x3, and simply filtering or mask processing is the operation we will see just now.